We were very pleased with all the entries. The jury was made up of high-caliber members and discussed very constructively and enthusiastically. After a multi-stage selection process, the jury nominated 3 companies as candidates for the main prize of 2,000 euros. The high-quality samples submitted met the requirements and already have a certain industrial maturity before entering the market. The jury was, of course, very pleased about that. I am very pleased to hand over the moderation of the Innovation Awards to my 2 colleagues, Martin Bussmann and Michael Walter, who were part of the 5-member jury. During the award ceremony, the winners will present the projects and will be available to answer questions afterwards. We would ask the winners not to run away after the event, as we would like to take a picture of you together outside. Thank you. Welcome on stage, Martin Bussmann and Michael Walter.
Thank you very much. Thank you very much. Now it works. Thank you very much for the kind introduction. As mentioned before, many thanks to all the participants, speakers, and last but not least, the organizer, Polycom e.V., and all the people behind this wall, the technical staff, the service clerks who made this great event possible. I would like to give them a round of applause. Thank you. So now we are proceeding to the award ceremonies of this year's BIOPOLYMER Innovation Award. I made some notes not to spill out any secrets before it is due time. We received entries from all over the globe again, thanks to all the participants for entering projects and products here, ranging from small startups to already commercial companies, from early development ideas to almost fully fledged commercial products. For the jury, as was mentioned before, it was a very tough decision, and sometimes projects were in a kind of early development stage, so we urge all the participants that are not mentioned this afternoon as nominees to maybe, if they reach another step forward in their development process, maybe to just reapply next year. The jury for this award consisted of members from the press, the industry, R&D institutes, and the organizer of this event, Polycom e.V. As part of the jury, Martin and myself, it was our task to decide for the nominees and the respective places. And it was a very close finish this year. For the first time, all 3 nominees come from Germany. That's a novelty. In former times we had international nominees, but this time it was almost anonymously decided that all 3 come from Germany. All 3 nominees are excellent examples for highly innovative products and projects and solutions for practical use. Thus, the decision for first, second, and third place was a very close one this year. In former years, it was the habit that we were introducing the projects of the nominees, but this year we thought about something else, because who would be better suited to introduce their projects and their products and their innovations as the innovators themselves. So this is why we will invite them on the stage and have them speak for themselves. So without further ado, we will start with the first nominee in alphabetical order, I have to stress, and that's the company Green Elephant from Gießen and Berlin, I learned today. Presenting will Felix Wollenhaupt. He's the co-founder and managing director of the company, and the topic is Cell Screw. The stage is yours.
Welcome.
So, perfect. Thank you so much for this nice moderation.
As you said, my name is Felix. I'm co-founder and managing director of Green Elephant Biotech, and I'm very excited today to introduce you to our product, the cell screw. I also brought one of it here. I can also pass it on later, so all of you can have a look and see for yourself. But before I jump into the product, let me briefly introduce our company, Green Elephant Biotech, to you as well, because we are the world's first company to create labware out of a sustainable material, in this case, PLA. Our mission at Green Elephant Biotech is to enable academic institutions on one side and on the other side companies out of the biotech and pharma world to really cut down their CO2 emissions on one side, on the other side also to bring technological innovation. And we think we delivered on that with our first product, which I will get to in a second. But also, just to give you a quick overview, this is our team. So right now we have 14 people located in Gießen, also in Berlin. I also brought my colleague here, that's Janine. And we have a background in the University of Applied Science in Gießen and are a university spin-off from that university and have been working on the technology for our first product since 2018. But before we jump into the product, let me briefly explain the main problem we want to contribute to solve to. So single-use laboratory waste. I'm not sure what your background is when it comes to cell culture, but among all labs worldwide, single-use products are used in almost every lab. And we think that's a massive issue. Just to give you a reference number, the whole German waste industry emitted about 9 megatons of CO2 equivalents in 2021. On a global scale, this amount was about 4 times that amount only related to single-use laboratory waste. And we think this amount is just way too much. And the worst thing about it is it's just not necessary because there are alternative solutions on the market, and we really want to bring these solutions to the market. So how do we cope with this issue? There are basically 3 ways to do with that: reduce, replace, recycle. What we see going on in the industry right now, especially in the biotech and pharma world, a lot of companies are focusing on the reduction part. So they reduce the amount of packaging, for example, for their products, or they cut down on the kilometers traveled by airplane from their employees. And we think that's really good, and that these are good initiatives, but they don't go far enough. On the other side, the recycle part is very challenging in that industry because a lot of materials are connected with potential infectious materials, and the recycling is therefore very, very difficult, and there are no good solutions on the market up until this point. So we at Green Elephant, we really focus on the replacing part. So we replace fossil fuel-based with sustainable materials. In this case, we use PLA. And now let me get to the product itself. So as I mentioned earlier, we developed the cell screw, which is a bioreactor. A bioreactor, its job of the bioreactor is to expand the amount of cells. You would given a small amount of cells, and you would cultivate those cells and would get out as a result large amount of cells. And there are certain ways how to do this right now in the industry. As you can see here on the top left are standard roller bottles. Just to explain for you in a second, so you would have basically a standard bottle, would fill it with cells and would put in cell culture, would put it on a roller device, would slowly rotate it, and by this rotation, the cells would grow on the inner surface of those roller bottles. You can imagine maybe for the nutrition and oxygen supply, this is very good for the cells. They have a very good environment to grow on the one side, but the scale-up is very challenging because the volume to surface ratio is actually very bad. On the other side, you have these multi-tray stack systems. Probably everybody in this room knows Petri dishes. And these are basically like large Petri dishes stacked on top of each other, sometimes up to 20 layers. And you can also imagine on this, for these products, it's right the opposite. You have a very large surface area, but very bad mixing for the cell culture media. As a result, some cell lines are not even good to grow inside because they demand more nutrition and other oxygen. And we thought it would be good to combine these advantages of both systems, of those roller bottles and multi-tray stacks, and have them in one product. And that's what we did with the cell screw. And on top of that, we also realized there should be a more sustainable way to create those systems. And we found out that actually 3D printing is a very good way. It allows us to cut down about 90% of the CO2 footprint in comparison to other systems with the same surface area. But what is special about the cell screw? So we basically introduced two different structures, and we highlighted these structures in a very transparent way so that you can see it. So in the inside, we do have an Archimedean screw. By rotation, this Archimedean screw will transfer the cell culture media through the whole bottle. And if it reaches the top, it will flow back through a small tube in the middle. And therefore, we have a circulation system inside. And around these Archimedean screws, we do have concentric cylinders as well, which make up a very large surface area. So on the same outer dimensions as a standard roller bottle, we have about 15 times the surface area and can therefore increase the processes by a factor of 15. Last but not least, I just wanted to highlight very quickly, right now we are in the process of fundraising again. We already had some successful funding rounds in the past, but we're just in the preparation for the next funding round. So if you have some investments in the past in the healthcare sector and also look to support a company with a sustainable product, really disrupting a market, then please feel free to reach out. We are very happy to get in contact with you. That's it from my side. Thank you very much for your attention.
Thank you. As you can see, this is a very, very interesting application of biopolymers in a very different field, as most of you are acting. For us, very interesting. But let me get back to honoring words later on, and let us skip to the next presenter of Sobico GmbH, Bad Sobernheim, Dr. Johannes Fuchs. And now we're changing the completely different area of bioplastics from applications now to plastic resin. Welcome on stage. Happy to have you.
Thank you very much. Ladies and gentlemen, welcome to my presentation. First of all, let me say it is a great honor for Sobico to be nominated for this award. And in the next few minutes, I would like to give you some information about Sobico and, of course, about our PLA copolymers. Sobico stands for Solutions in Biocompounds, and we are a subsidiary of the Polymer Group. And we are founded in 2020. However, the research work in the field of PLA copolymers goes back to 2015, when we started a joint research project with the Fraunhofer Institute for Applied Polymer Research. Our production site is located in Versfeld, about 100 kilometers southwest of Frankfurt in Germany. And currently, we have a pilot plant with a capacity of around 2,000 tons. However, the plans for the expansion of the capacity to 10,000 tons are already well advanced. And at the moment, we supply our customers with sample materials which are tested on their pilot plants and production lines. Yeah, where was the starting point, or what was the initial problem? In this diagram, you can see the various fossil-based plastics in red and the selection of bioplastics in green. And as you can see, PLA is a very stiff and brittle material with a Young's modulus of about 3,500 megapascal and an elongation at break of about 3%. So we wanted to modify a PLA so that it would have properties very similar to LDPE and could be used to make flexible films. And one possibility is to use plasticizers. But these plasticizers can migrate, as you can see on the screen, and also they have a more or less bad reputation among consumers. So our approach was not to produce a compound from PLA and plasticizer, but to develop a copolymer. And in addition to lactide, the main component of PLA, it should contain a comonomer that gives the copolymer flexible properties. And we used polyol for this purpose, and this soft component is covalently bound into the polymer chain. And to produce our PLA copolymers, we use the reactive compounding process, which we had to optimize for our purposes. And the procedure is as follows. First, we add lactide and a polyol and a catalyst. Then the PLA copolymer is synthesized. At a certain point, we add a deactivator to stop the polymerization process. After that, we extract the remaining monomers. Then we can add various additives, fillers, or fibers. And finally, we obtain a PLA copolymer compound. Yeah, and the reactive compounding process and the right ingredients give us a metamorphosis of a material, and we call this material Plaktit. And we can achieve bio-based content between 80 and 98%. We do not use any plasticizers and therefore have no migration. And the material is very easy to use in traditional production processes. And by varying the polyol content and types and the process parameters, we can tailor the properties of the copolymer for different applications. So that means Plaktit types with elongations at break of up to around 400% are possible. And the increase of elongation at break is naturally accompanied by a reduction in Young's modulus. Also, we can selectively adjust the modulus from values for standard PLA, like 3,500, down to about 100, 200 megapascal. Yeah, the areas of application are wide-ranging. To begin with, we are concentrating primarily on flexible films, but in the future, we also want to provide optimized solutions, for example, for toys or 3D printing or the construction industry. With my last slide, I would like to make some acknowledgements. First of all, I would like to thank the whole Sobico team for the hard work during the last years. I also would like to thank the Fraunhofer Institute for Applied Polymer Research, and especially Dr. Antje Lieske and her team for the many years of cooperation. Many thanks to Polycom for the nomination for this award. And last but not least, I would like to thank you, the audience. Thank you very much.
Thank you very much, Mr. Fuchs. As you can see, a variety of different topics. Thank you very much for that introduction. And I would be happy to shift to the next presentation and welcome Mr. Stefan Fischer of the TITK EV Rudolstadt Institute, talking about something, again, very different. And then you can already estimate how challenging it was as jury to select something, and there was by far more arriving this year. But he will talk about a bio-based hot glue. And I would like to give you stage and the opportunity to present your project.
My name is Stefan Fischer. I'm a research associate from the TITK. And before I start, I have to add some information. I'm here by proxy. My colleague who should present this became father last week, so I'm doing it. So, yeah. Okay. As I said, I'm from the TITK. This is Thüringisches Institut für Textil- und Kunststoffforschung. We are located in Thuringia, and the institute was founded in 1991. We have around 200 employers, and the TITK has two subsidiaries, UMPG and Smart Polymer. The institute itself consists of several departments. I'm from the department Native Polymers and Chemical Research. We are not so much doing basic and fundamental research. We are more interested in industry-oriented research. So, oops. Yeah, what is the driving force for our work, or what was the driving force for this project? On this slide, you see a forecast of the market for hot melt adhesives and biopolymers for the next decade. And yeah, as you can see, the experts expect a dramatic increase of the market volume. So there is also a dramatic increase and an increasing demand for biopolymer, for bio-based hot melt adhesives. So if you want to create a bio-based hot melt adhesive, you can simply think of, yeah, okay, let's replace all the petroleum-based hot melt components with bio-based alternatives. But as the representative of Husky already mentioned, it's not that easy. In the case of hydrocarbon resins, it is easy, and also in the case of the waxes, it's quite easy because there are already biopolymer, bio-based alternatives on the market. For the polymer itself, PLA, or for the polymer itself, ethylene vinyl acetate or polyolefins, it's not that easy. There are just two polymers available, PLA and PBS, as alternatives. But there is just a small range of materials, meaning the industry just offers a few grades and you can vary that much. They are not designed for hot melt adhesives. Normally you use them for films, fibers, 3D printing and so on, but not for hot melts. Because they are brittle, the viscosity is too high, and also the melting point does not fit to the purpose. They also have a poor compatibility with most resins and waxes. That means when you combine them, heat them up, and try to form a melt, you simply have a phase separation and not a homogeneous melt. Another big problem, this was also mentioned today, is the weak thermal stability. So when you heat it up for several hours, you will have hydrolysis, and the polymer chain will cleave, and you soon get to a viscosity drop, and it's not working anymore. So we had to solve these problems, and the technical problems were simply solved by using bio-based softeners and a combination of PLA and PBS. You might say, okay, softeners are not what we want, as we heard in your lecture before. But we used a bio-based softener. It's a citric acid ester. The thermal problems were solved by using extrusion technology instead of standard batch technology. This reduces the time and also the temperature the mixture has to endure during the process. And the final problem with the bad compatibility was solved with cooperation with resin manufacturers to use chemical modifications to increase the compatibility. So the TITK I mentioned before, we are doing, so to say, the research, and our two subsidiaries are responsible for quality management. They are also doing material testing and analytic stuff. And the Smart Polymer, this is a manufacturing subsidiary, and they are also responsible for the marketing, so we can offer the entire package. Thanks for your attention, and I also have one of these sticks with me, so as you can see, it is quite flexible, and we can discuss it in the break if you like to. Thanks for your attention.
Thank you very much, Stefan Fischer. You have seen now, we shouldn't block the trophies, we were told. You have seen now, or heard for yourself, that this is a high caliber of nominees we have this year. Huge diversity as well. So which company, which product, which innovation would you have chosen? I'll give you a few seconds. But let's not build up the tension too much. So without further ado, let's start with the awards ceremony. It's my great pleasure to award the prize for third place of the 2023 Biopolymer Innovation Award to Sobico GmbH. Dr. Johannes Fuchs, MD. Would you come to the stage, please? Presenting the prize will be Peter Putsch, chairman of Polycom e.V.
But let me, in the meantime, get you some reasons why we have chosen you as third winner. For us, it is a result of a long-term R&D work in cooperation with the university. For us, it's a new approach in the PLA world, which we have, as jury, not seen before, and which is for us a kind of outstanding result in that kind of landscape. We have seen this amongst the, as we said, many submitted innovations as one of the top three. So, this is for us the reason why I've chosen that, and it was a more unique thing, and we hope that you'll commercialize it soon, that we'll see it in applications pretty soon in the markets, and hope to have you next year as well in this kind of conference with a presentation on applications and new things. Thank you so much.
Congratulations also from my side.
Jetzt muss erst die Begründung sagen.
As you can imagine, as soon as I announced the second place, there's not too much to think about who might be the first place tonight. But second place, and this year's runner-up is...
Let me give you the reason before.
Okay.
Let's keep the tension a little bit up.
Let's do it like this. That's fine.
So as you can imagine, and you did your ranking before, as you said, Michael, it's very tough. Now we have a hot melt versus an application in the medical world. As you can see, this is so tough to decide at the end, because both have their own advantages and disadvantages, and even the maturity in the markets as well. For us, both have a very clever approach using biopolymers. One biopolymer is used in a non-degradable applications, as we've seen from Green Elephant. The other one is more designed for degradability as one end-of-life option, but using also biopolymers itself. Both of them have been ranked in the jury as the ones who had been fighting the most to be the one which would be on position number one. At the end of the day, and here comes the final result, Michael.
Should I do it?
Yes.
Okay. Second place is Green Elephant. Felix Wollenhaupt.
For us in the jury, it's an outstanding application with a new approach, a new design, using bioplastics, as you have done pretty well shown in your presentation. And we wish you all luck. We hope that the prize will support you to bring that alive. We've seen it in the past years, by the way, and that's something we missed to mention, that the prize boosted also the companies in that way. And we keep our fingers crossed that it will also happen for you. And we will be very happy to see you with a lot more success, not only in fundraising, but also in the application, seeing it in the labs. Thank you so much for applying. Danke.
Which means we have a winner of the 2023 Biopolymer Innovation Award.
Correct. And for us, the glue is interesting in terms of different applications, different industry. The approach is thought very wide and very focused on different applications. It's also been a substitute of 1/5 of the adhesives in the markets worldwide, which we think is an outstanding approach. And you've seen that the team itself did it very clever in looking and finding the applications on a technical level, but also having the constraints of an institute itself. So it's not a company approach with a lot of money behind. For us, it was driven out of the idea of the team. It was people, as also for the other ones, behind that, which led us to the 3 nominees. But that was also outstanding for the care melt for us. it's not only biodegradable, but it has the same also vision as the other ones, being a CO2 neutral adhesive in the market. And this tiny component of an adhesive is usually a kind of project killer, what I know from the past. So we also need to go for the tiny things to change the world and not having the large ones first, which most of the people think is the game changer per se. So the glue is patented. And is ready to sell. We've not heard it yet, but we think you'll also get some finance and production support to bring it to life. For us, it's the outstanding research work, and that's what it needs to be deserved, the award. And we're happy to welcome you on stage and handing you over the first prize, the Biopolymer Innovation Award of 2023.
And the cash prize of 2,000 euros.
You're welcome. Komm noch ein bisschen näher.
Ja, thanks.
Gut stehen bleiben.
So, thank you very much for joining us in this afternoon session of presenting the awards. I would like all winners to come up stage, please, for a final picture of all the winners.
And in the meanwhile, I'd like to thank everybody who submitted their projects, their ideas, their samples to us. We had so many as we've never had before in the years, and we like to encourage every one of you to submit also your ideas for the next Biopolymer Innovation Award for next year. Wir gehen an den Rand. Ja. Bitte. Plätzchen. Excellent. Thank you, everybody.
Thank you very much, and congratulations to all the winners. And this concludes the award ceremony session, and we'll hand over to Julita.
Danke. Thank you.
And many, many thanks to my two colleagues, Martin Bussmann and Michael Walter, who very nicely hosted the award ceremony. I couldn't have done it better. And of course, many, many thanks to the winners and the impressive presentations. I warmly congratulate you on the prizes. We wish you all the best and every success with your market entry. Thanks very much. And I would like to draw your attention to one thing. Ladies and gentlemen, this whole session was filmed and pictures were made, and the whole session will be published on YouTube. And if you don't agree with this, please contact my colleagues in the back and let us know. So this is just a note for you before I get to an end. Unfortunately, I'm sad, ladies and gentlemen, because the Congress is over. But this was this year's Biopolymer Congress. And we do really hope it's been informative and enjoyable, and that you'll take away many new insights and ideas. Thank you so much for your attention, your interest, and the active participation. Next year, we are planning another live event where we can exchange ideas and network and direct contact. But we can already tell you this much: Australia will be our partner region in 2024. And if you have time and the desire, we would be very pleased if you would give us a short feedback on our Congress so that we can continue to improve next year. You will have the opportunity to do so in the email you will receive from us after the Congress. We would like to thank you in advance and look forward to receiving your feedback. Many, many thanks to our great supporters and partners, the Federal Ministry for Economic Affairs and Climate Protection, EPMA, Exypnos and Rubio. And we would like to thank the Georg Friedrich Händel Hall and the technical team in the back once again for the outstanding support. We are indebted to this wonderful team without whom this event would not have been possible. Many, many thanks. And of course, we look forward to seeing you again on June the 11th in 2024. Take care and stay healthy. See you next time. And now, the chairman would also like to say goodbye to you all personally. Thank you very much. It was a pleasure for me. Thank you and goodbye. Thank you very much. Thank you.
Yes, as chairman, I have the last word. At first, I would like to thank all the moderators, the technical people, our ceremony master, and all people that enabled this very nice meeting and conference. And I hope that also the spectators online and here in the hall enjoyed our Congress and will join us also next year. So the date is already fixed. It is the 11th June 2024. And as was mentioned already before, our partner country this time will be Australia. So we found out that there is a real active biopolymer scene down under, and we are very keen to and looking forward to have them as partners. So, okay, then I say goodbye, and mostly to all the online spectators. Here are the spectators in the hall. I would like to inform that we have wine and dine tasting, so don't escape. We prepared everything in the foyer, and yeah, so I wish you a good travel home, and see you next year. Thank you.